Okay, I was thinking about how to bridge the gap between a purely frivolous example like the one we just did, which might have been a little bit fictitious, but at least it got us the mechanics, right? We now know how to average any probability distribution. Just add up all of the random variables times their probabilities. And what's so cool about this is we can average anything like this if we can get it into a random variable distribution. So I was thinking, what's a good way to bridge the gap between one like that and one that involves money? And I said, wait a minute. Vegas exists because we can connect money to things like dice. So I decided, let's as our next example, let's look at craps and how craps works for the casino. So if you've never played craps before, it's an interesting experience. I've never played craps in a casino. I have my students in Math 105 play it whenever we have class together. This is what a craps table looks like. It's definitely a sensory experience to see one of these things in person. And whenever I've noticed people playing craps in casinos, they're usually having a pretty good time. Why are they having a pretty good time? Now, I don't want to get into the mechanics of craps right now because it's only really fun if we can play it together in class. But I will tell you this. There's a special kind of a bet called the pass line bet in craps. You may have heard the phrase snake eyes or lucky seven. Those are all tied to the pass line bet in craps. And if you're interested more, you can always ask me and I'll fill you in, or just Google it. I mean, there's thousands, if not millions, of web pages devoted to trying to win at craps. What you're about to see is how you can't. You can't win at craps in the long run. Just wanted to take a quick pause and reiterate something I just said, because when I tell people what I just said, oftentimes they'll say, yeah, well, I had an uncle once that won a bunch of money at craps. I'm not saying you can't win in a short period of time at craps if you then walk away with your winnings. I'm saying if you continually play craps over and over and over again, you will end up with less money than you started. We're about to see why mathematically. That's what the averaging is all about. So the emphasis is on the long run. Trust me, if you could win at craps in the long run, or roulette, or on a slot machine, they wouldn't be in casinos. The reason those games are in casinos is they are guaranteed income for the casino. Let's take a look why. Because the chance of winning on the pass line bet is mathematically 49.29%. That is the way the dice fall. 49.29% of the time, you win. That means you lose the other, what would that be? 50.71% of the time. Subtracting these two numbers gives you something that's known as the house edge. Now, if you look at those two numbers, they're very, very close, and they're extraordinarily close to 50% each. But the house has a little teeny tiny bit of an edge right there. And that's how they collect their money from you. Now, what I'd like to do is I'd like to start putting this into a probability distribution and see how Vegas is able to generate its money. It's not quite as simple as just this probability is bigger than this one. It has to do with the money involved. Let's take a look at that. Okay, here's the beginning of it. So we've got our P of X column figured out. They both sum up to 100%, so we're okay there. What we got to do now is figure out, what do you win when you win, and what do you lose when you lose? Or I guess, what do you win when you lose? Here's how the bets work on a pass line bet. Let's say you walk up to the table and you bet $5. If you bet $5 and then you play one round of a pass line bet and you win, the casino hands you $10 back. It's called a 2-to-1 payout. For every $1 you bet, they give you 2. But here's the deal. If you paid 5 to play and they hand you back 10, you've only won $5. You're $5 in the hole for starters. That's the key to Vegas's success for games like craps. You have to, it's called anteing up. Ante, A-N-T-E, meaning to happen before. You have to pay that $5 first. Yeah, then if you win, they're going to give you 10. Absolutely true. But what if you lose? Well, if you lose, you're $5 in the hole. Sometimes spreadsheets will actually put these things in parentheses to take a look at it. Let's actually go to a spreadsheet right now and calculate the average winnings of craps based on our probability distribution.
All right, I've taken the liberty of just putting our distribution into Excel for us. It's kind of cool, actually. I was using the dollar sign to enter the numbers 5 and -5, and when I put the -$5 in there, I got this cool like bookkeeping formatting. It made the amount red and it put it in parentheses. I did not do that. That was automatically done by Excel, so that's pretty cool. All right, so if we want to figure out on average how we're going to do, we just have to create one more column. You can already see what's happening, right? X times P of X. You can see already that this win and this loss offset each other exactly equally. They're going to sum to 0. But this probability is a little bit less than this, so you can tell what's going to happen already, I hope, is that the amount you win on average on that $5 bet is not going to cover the amount you lose on average. So by adding these together, this is the definition of the average, right? We're going to add those together. There's no need to divide by anything because the division has already been taken care of over here in the probability column. So what does this tell us? This tells us that on average, when we bet $5 on the pass line of craps, we can expect a loss of 7 cents per bet. 7 cents loss per bet.
Here's another way to view that loss of 7 cents. When you bet $5 at craps, you come up, put your chip on the table, play the game, and then you either win or lose. So you either get $10 handed back to you or you get $5 left on the table. A way to view the average is this. Walk up to the table, hand them $5. The dealer then hands you back $4.93 and keeps the 7 cents. Now that might sound stupid because it doesn't actually happen, but that actually does happen for Vegas in the long run. If you actually take all of the wins and losses that happen over many, many trials in many, many games of craps, the average on the pass line bets is going to be a net loss of 7 cents for the player and a net gain of 7 cents for the casinos. Sure, people win 49.3% of the time, right? But the losses, the other 50.7% of the time, make up for the wins enough so that Vegas averages 7 cents per game. Let's look at another craps bet. This has got me thinking about craps now.